So the photoelectric effect first the equation that energy of the photon, energy of the incident photon is equals to work function plus kinetic energy of electron. Or we can also say, in terms of symbols, we can write energy of the incident photon is E, work function is phi, kinetic energy is half mv square or ke. Or because at a stopping voltage, electrical energy equal to kinetic energy, so we can say E is equals to phi plus electrical energy, so that is V naught E or V naught Q. V naught is a stopping voltage which will stop the electron from moving, and E is the charge of electron. If we sketch a graph between the energy of the photon and the kinetic energy, so the graph between energy of the photon and kinetic energy, on x-axis, if I take energy of the incident photon, and on y-axis I'm taking the graph for the values for kinetic energy. On x-axis we have the energy of the photon. So what happens as we increases the energy of a photon, all the because this will start at a specific energy, the electron will not come out at all the energies. At a specific energy, the electron will come out, and when we increase after that, like this is the energy at which electron is able to come out, then after that, when we further increase the energy of a photon, the kinetic energy will also increase. So the graph will be a straight line. If we are using a different metals with different work functions, so this is for metal A, this one is for metal B, and this is for metal C. Which metal is having the higher work function greater, because this is the minimum possible energy at which the electron is being emitted, so that is phi 1, or you can say phi A. Phi is the minimum possible energy, A is for metal A. Phi B, minimum possible energy for metal B, and phi C, the minimum possible energy for metal C. So phi A, phi B, and phi C. So to remove the electron out, metal C is having a higher work function as compared to metal B, and metal B is having a higher work function as compared to metal A. So increase, why there was, like in the why this part there was no kinetic energy for electron, it means the energy of the photon was less than the work function in this region, that's why there is no kinetic energy. Same thing, we can also plot a graph between the frequency of a photon and kinetic energy, which is more useful. How the frequency graph is more useful, the shape will be same. How the frequency graph is more useful, because you have the formula that energy of the photon is the phi plus kinetic energy. We are plotting a graph. On y-axis we have kinetic energy, so so and on x-axis we have frequency. Sorry, on y-axis we have frequency. Yeah, on x-axis we have frequency, on y-axis we have kinetic energy. So we want the equation, we want y is equals to mx plus c. We want to rearrange this equation. So quantity which is on the y-axis should be separated. So if I move phi to other side, so it will become E minus phi is equals to Ke, or I can say Ke is equals to E minus phi. And what is E? E is the energy of the photon. In the beginning of the session we discussed that the energy of a photon E is equals to hf. So in place of E I can write hf. So kinetic energy is equals to hf minus phi. Now if I compare this with the equation of straight line, y is equals to mx plus c. So you can see if y-axis I have kinetic energy, on x-axis if I have the frequency of the photon, so my gradient will be equal to the Planck's constant, and the y-intercept, the negative y-intercept, the gradient will be equal to Planck's constant, and the y-intercept or negative y-intercept is equals to phi. So shape of the graph will be identical. Like on x-axis you have frequency of the photon, on y-axis you have the kinetic energy of the electron. And we have this equation where when we worked out that kinetic energy is equals to hf minus phi. So when we increase the frequency of a photon at a certain frequency, the photoelectric effect will take place. The minimum frequency at which the photoelectric effect will take place, that is known as threshold frequency. It is a minimum frequency at which the photoelectric effect will take place. And when we increase the energy of the frequency of a photon, the energy of a photon increase, so electron will come out at a higher speed, so they will move faster, the kinetic energy will also increase. And if we extend this line backward and find a y-intercept, so this kinetic energy, the negative y-intercept, as you can see, the negative, when you compare with the equation y is equals to mx plus c, so this negative y-intercept is showing work function, minimum possible energy to remove electron. And if I find the gradient, that will give me the Planck's constant. So the graph between the frequency and kinetic energy is more useful. It is identical, shape is same as the energy and kinetic energy of a photon and the kinetic energy of electron. This graph is same as energy of a photon and kinetic energy of electron, as you can clearly see. But this graph does not give other variables, other quantities. But frequency graph is more useful, as the y-intercept, negative y-intercept is equals to work function, and the gradient is equals to Planck's constant. Is it clear, the concept of the photoelectric effect? So these graphs are important, the idea of the photoelectric effect, how the particle nature is able to explain photoelectric effect, and wave nature is not able to explain this effect. Then the last topic of this unit 2, spectrum. A group or a band of energy is called a spectrum. And spectrum is divided into two categories. One is called a continuous, another one is known as discontinuous or line. What is the meaning of a continuous spectrum? Continuous spectrum does not mean, the term continuous does not mean continuously the energy is emitted. It means you have a range of energy. In a continuous spectrum, you have a range of energy released. And in a discontinuous or a line spectrum, it is a discrete or fixed amount or specific amount of energy is released. Like I will explain the idea what is a continuous spectrum. Example, you have a discharge tube which is filled with helium, and you connect an AC supply to this. So when you connect an AC supply and there are helium atoms inside, due to the continuous change in electric field, the direction of electric field, what it caused the helium atoms to vibrate. When these helium atoms vibrate, some will vibrate faster, some will vibrate slower. So the one which is vibrating faster will release more energy, like example that is releasing 10 joule. One which is vibrating slower release smaller amount of energy. One is vibrating moderately, like average 5, so 6, 7, 8. So what you have a range of energy. When you receive a range of energy from the source, what we call this energy, what we call this spectrum, this spectrum refers to continuous spectrum. Continuous spectrum means you will have a range of energy. Like example, and each energy correspond to a color, like you have violet, indigo, blue, green, yellow, orange, and red. So when you receive the energy from this, and if it is in a visible range, what you will see a range of colors. As you are able to see range of colors, this type of spectrum, this type of energy emission is known as continuous spectrum. But what about the line spectrum? What is the meaning of line spectrum? Line spectrum is also known as atomic spectrum, and it is also known as the fingerprint of element. Basically what happened, this is a nucleus. The first shell you will have electron, the second shell electrons are there, third shell electrons are there. So this is E1, shell 1, energy 2, and energy 3. Say shell 1, electron is there in the shell 1. For all the atoms there are 7 shells occupied. The number of the shells occupied depending on the number of electrons available. Like even in case of hydrogen, when we say hydrogen, hydrogen is having 1 electron, but number of the shells are 7, but occupied are different. Different number of shells are occupied, like because the only 1 electron is there, so 1 electron occupies the first shell only, the lower or the at a ground state. Now what happened when this electron absorbed, and this line spectrum can only be explained by a particle nature of the light. The wave nature cannot explain this. So example, to jump from shell 1 to shell 2, this electron need say 5 joules of energy to jump. The minimum energy required to jump from first shell to another, it is 5 joule. But the energy of the photon is 3 joule. Will this electron jump to the higher level? Is there a transition of electron from lower to higher level? There is no transition because the energy is not sufficient. It needs 5 joules of energy to transit from shell 1 to shell 2. An example, it needs 15 joules of energy to transit from shell 1 to shell 3. Now, example, if there are two photons, one of energy 3 joule, another one of energy 2 joules, will this electron jump to the from first shell to the second? Is there a transition? Again, there will be no transition. Why? Because each electron absorbs one photon at a time. It cannot absorb two photons. So this will not occur. But if the energy is, like example, 5 joules, then what happens? This electron will absorb and it will jump to higher shell. So when electron absorb a specific amount of energy, a fixed amount of energy, we call that as absorption light spectrum. But electron cannot remain in this shell for a longer period of a time, so it will jump back, return back to its same, and it will release a photon, and that is called emission line spectrum. So line spectrum is divided into two categories. One is called emission, another one is absorption. First, it will absorb a photon. Why we call that a line? Because there is a fixed amount of energy absorbed by the electron. And why we call absorption? Because it absorbs energy. When it will return back, it will release energy. So if we have a shell, like, and why we call that as a fingerprint of the element? What is the reason? Like if you have a sodium nucleus and you have hydrogen nuclei. Sodium first shell 2 electron, second shell 8 electron, third shell 1 electron. For hydrogen, but there are 7 shells, so other shells are there occupied, not occupied. 4, 5, 6, and the 7th one. For hydrogen 1, 2, 3, 4, and when we move to higher shells, the gap, the difference between the shell decreases. 1, 2, 3, 4, and 5 is there. Even overlapping can occur. 6 and 7. So why we call, like example, in sodium we have first shell 2 electron, second shell we have 8 electron, or instead of sodium, take example of lithium or helium, so that we can compare them. Now what happened? This is shell 1 for helium and this one is shell 2. Shell 1 for hydrogen and shell 2. So when electron jump from shell 1 to shell 2, you can clearly see the gap, the shells of helium have different energy, different gaps as compared to shell in hydrogen atom. So this required different amount of energy. Like example, hydrogen required a 3 energy photon, but helium required a 5 energy photon. So they need a different amount of energy to jump from identical level. That's why different elements have different line spectrum, and that is why the line spectrum is also known as the fingerprint of the element. So using a line spectrum, we can identify that what is the composition of a material or which element is present inside the material. Or using a line spectrum, we can also say the composition of stars, like what are the elements present in the following specific star. So when we draw, because it is difficult to draw all the shells, but horizontal, when we draw in this manner, it is easy to draw. So 1, 2, 3, 4, 5, 6, 7. So there are 7 shells. Example, electron is in the first shell. So electron is in the first shell. So to jump from first shell to second shell, example, it need a 15 joules of energy, and photon is having a 15 joule. So what will happen? It will absorb and it will jump from first shell to another second shell, and this is called absorption line spectrum because it is absorbing a photon. But after some time, because electron does not belongs to same shell, this shell, so it will return back, and when it will return back, it will release the photon. And how we'll know what is the energy of a photon release? That will be equal to E2 minus E1. The energy of a photon, which is E2 minus E1, the difference in the energy of the shell, which is equals to HF. And if we supply, yeah, it needs less energy to jump from second shell to third shell, because as the shells are closer, it means the energy gap. This gap is showing the like the difference between the shell is showing the energy gap. But if we have electron in the first shell and we supplied, like electron is in the first shell, the shell from which electron belongs to, that is called a ground state. So ground state does not mean, like example, first shell, it means like the shell in which the electron belongs to, that is called a ground state. So to jump from first shell to third shell, example, it needs 25 joules of energy, and we supply a photon of 25 joule. So instead of electron jump from first to second, now it will jump from first to third shell. And after some time, it will return back and release the energy equal to, what will be the energy release here? That will be equal to E3 minus E1, which will be equal to energy of a photon release, or we can also say HF. When it is absorbing energy, we call absorption line spectrum, and when it release energy, we call that as emission line spectrum. So line spectrums are both types. One is emission, other one is absorption. But normally, when we represent the energy of these electrons, instead of using joules, we use another unit, we use electron volt. And the formula, like the relation, the equivalence, 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. But when you substitute this formula in this formula, when you use the formula, E is equals to HF, always use energy in joules, because the Planck constant formula, the Planck constant value 6.63 exponent minus 34, that is constant when the units are in SI, like standard SI system international unit. But normally when they give you the values, they provide in electron volts, so you can just convert these electron volts into, you can convert this electron volt into joules. So if I say this one is minus 13.6, this one is minus 4.8. What is the reason for minus? here you have a nucleus. So because it's a binding energy, the energy is binding the electron within the atom. That's why it is negative. Negative is only just showing a relation that it is binding the electron in an atom. That's why it's showing a negative value. Minus 3.14. So if I say what is the energy of the photon emitted when electron transit, because if I say emitted, it means it should transit from higher shell to lower shell. If I say absorbed, then it will be from lower to higher. So if I say what is the energy absorbed in a transition A, so how you'll find energy absorbed in transition A? Just E2 minus E1. So E2 is minus 4.8 minus, and that is in, this is electron volt, EV. So minus 4.8 minus and then minus 13.6. So this will be minus 4.8 minus minus plus 13.6. What's the answer for this? 13.6 minus 4.8 plus 13.6. How much energy will be absorbed? So that is equals to 8.8 electron volt. But if I say what is the frequency of a photon which is absorbed, so how you can find a frequency? So you cannot, you have the formula E is equals to HF, but the problem is that in this formula you should have energy in joule. So first I have to convert electron volt into joule, and we know 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if 8.8 electron volts, then it will be equal to x joules. Cross multiply 8.8 multiplied by 1.6 exponent minus 19. What is the answer? 8.8 multiplied by 10 to the power minus 19. It should be in exponent. Exponent minus 18. Okay. 1.4. So now you have 1.4 into 10 to the power minus 18. And the Planck's constant is 6.63 into 10 to the power minus 34. And frequency you're finding. So 1.4 into 10 to the power minus 14. Sorry, minus 18. This was 18. So 1.14 into 10 to the power minus 18 divided by 6.63 into 10 to the power minus 34. What is the answer for frequency? This is minus 18, negative 18. That's equal to 2.12, and this should be exponent 15. So 2.12 into 10 to the power 15, and the unit of frequency is hertz. So you will get the frequency of this photon. Even a transition is from lower to higher, higher to lower, you will always use E2 minus E1. When it is, this is called absorption, and another one is emission. But both are line spectrums because a specific amount of energy is being absorbed or released, and this gives an evidence of the existence of the shell, as well as the discrete levels are there, and we can use it to identify the elements as well. Then what is a laser? What is the laser abbreviation? Laser is a meaning light amplified by stimulated emission of radiation. What is the meaning of light amplified by stimulated emission of the radiation? Like laser, normally you have helium neon lasers. Example, this is one atom. This is another atom. Then this is another atom. Now, atom 1, atom 2, atom 3. In laser, you use a cell, so that cell will provide energy which will excite the electron. Electron will jump from lower shell to higher shell. But this will take time to excite. All the atoms are not excited at the same time. Electron, like for example, atom 1 is excited first, so electron move to higher shell. Then atom 2 also, electron move to higher shell. Then atom 3, electron move to higher shell. Now what happened, because atom 1 was, there's a time interval to which these electrons can remain in this second shell or third shell, because they are not belonging to this shell. So as they return, they will release a photon. So when it releases a photon, this photon, which is a particle, collide or interact with the electron of another atom, and that will force the electron to jump back to lower shell. And when it will force this electron to jump back to lower shell, so now there are two photons. Why two photons? One which is collided with the first atom, the second atom, and the one which is released due to the transition of electron from second shell to another. And then what happened, again this photon will interact with the electron. It will force the electron to jump back, and now as a result, what happened, we have three photons, the two which are already due to the transition of the first two atom and the third one. So basically, light which is amplified means when you increase a amplitude of something, you call amplified. It started with one photon, but as a result you are getting three photons, so you amplified the number of the photons. And why we call that as a stimulated emission? Because we make this electron to bounce, to return back to the shell, so we stimulate this emission. That's why we call that as stimulated emission of radiation. So first electron of an atom 1, 2, 3 all jump to higher shell, but when the atom in which the electron transit first, that will return back. And as this electron will return back to the ground level, the lower level, it will release a photon. That photon interact with electron of the another atom, that force that electron to bounce back, because this photon is not having enough energy to, so that electron can jump to higher level. So this force collide with this electron, force this electron to jump back, release two photons, one which is interacted and one which is due to transition. And out of these two, one of the photon interact with and stimulate emission for the other atom, then one is released due to transition and two of them which are already released. So it is multiplied. That is why laser light, you will find it is having a high intensity, and it can have a greater range before it is being absorbed by the material. Is it clear how the laser works? And the atoms which we use here, it use helium and neon atoms, a mixture of helium and neon. Is it clear? This concept of the laser, the light which is amplified by stimulated emission of radiations. So first electron jump, when it will return back, it release a photon that collide with an electron of another atom that force it to come down, release a photon, but two photon now, and out of these two, and this process multiplied, and which will produce a high intensity beam of light. That's why it is called a laser, means the light amplified by stimulated emission of radiation. So this is the last topic of unit 2. We completed unit 2 as well. Next session we'll do questions from the light to improve your understanding of topic light, and we'll move on to unit 3 discussion. Any question related to the class today? So I'll end the session and share this recording with you.